Hello kiddos, how are you? I really hope you are doing pretty much fine and that you are taking care of your health and the health of your family. In this case, we're going to start to working on a review of our physical science material for this third bimester exam. And obviously we're going to start talking about chapter number 4, which is about atoms and bondings. And in this case, we're going to be talking about four specific lessons. In this case, atoms, bonding, and the periodic table. By the way, that periodic table is going to be like a very fundamental part of your materials for your exam to be done. We're going to talk a little bit of ionic bonds, covalent bonds, and bonding in metals. So let's do it. About atoms, bonding, and the periodic table, basically the main question or key question that we are going to be trying to answer about is to explain what determines an element's chemistry. First of all, you have to remember the definition of the term electron. And if you go to the vocabulary terms on this lesson on page 125, you are going to see that two of the vocabulary terms include this word. I'm talking about, obviously, the term electron. You shall know that valence electrons are the outermost electrons in an atom and that an electron dot diagram is a way to represent these electrons. Valence electrons are a very specific set of electrons in an atom, and that these electrons you should remember that help determine the element's chemical properties. So if we are going to be trying to understand that periodic table, well, first of all, we have to remember that the elements on the periodic table are arranged in order of increasing atomic number. The elements are also grouped by similar properties, and for example, helium's physical and chemical properties are much more like those of neon, and argon than those of beryllium and magnesium, just to point out the idea of what I have just been saying. Another thing that you should be able to remember is that the number of valence electrons also increases from left to right across a period. Okay, so if you see in this slide, you have an image where you have some elements there that can give you a better idea of how many valence electrons could you know that a specific group on the periodic table can have. For example, if you look in this case at hydrogen, right? Hydrogen is over here, and hydrogen is on group number 1, better known as the alkali metals. And in this case, they are going to have all the elements including hydrogen and below it are going to have only one valence electrons. But for example, if you go here a little bit to the right and you see at beryllium, which is an element that is you can find it on group number 2, better known as alkaline earth metals. All the elements below beryllium on the periodic table are going to have 2 valence electrons. If we go, for example, to group number 14, where we can find the carbon family, that means all the elements that are below carbon, they are going to have 4 valence electrons. And finally, at the most right side of the periodic table, you are going to find the noble gases. And in the noble gases, you can find helium. And in this case, noble gases are always going to have 8 valence electrons. When an atom loses a valence electron, it loses a negative charge and becomes a positive ion. When an atom gains an electron, it gains a negative charge and becomes a negative ion. An ion, for example, is an atom or group of atoms that has an electric charge. It does not have the same number of protons and electrons. Positive and negative ions attract each other because oppositely charged particles attract, right? The attraction between two oppositely charged ions is called an ionic bond, and the substance formed is called an ionic compound. Ions that are made of more than one atom are called polyatomic ions. Ions are usually formed by the elements on the edges of the periodic table, those in groups 1, 2, 16, and 17. Remember that group 18 elements have 8 valence electrons and they are already stable. If we were trying to answer the question of how are the formulas and names of ionic compounds written, first of all, we should be able to say that a chemical formula is not unlike a formula in mathematics, obviously. Instead, it is a combination of symbols that shows the ratio of elements in a compound. For example, the formula for sodium chloride is NaCl, right? To write the formula for an ionic compound, you have to write the symbol of the positive ion, and then you're going to write the symbol of the negative ion. Add the subscripts that are needed to balance the charges, and for an ionic compound, the name of the positive ion comes first, followed by the name of the negative ion. So, another question important to be answered in this case will be, what are the properties of ionic compounds? In general, ionic compounds form hard, brittle crystals that have high melting points, and when dissolved in water or melted, they conduct electric current. For example, a fluorine ion has a charge of -1, right? An aluminum ion has a charge of +3. So here's an exercise for you. On a separate sheet of paper, try to explain how fluorine and aluminum will exchange valence electrons to form an ionic compound. Then you're going to be trying to write the compound's chemical formula and name the compound. Good luck. When two atoms share electrons, instead of gaining and losing them, the chemical bond is called a covalent bond. The attractions between the shared electrons and the protons in each atom's nucleus hold the atoms together in a covalent bond. The substance formed by a covalent bond is called a molecule. If two atoms share two pairs of electrons, the bond is called a double bond. If the two atoms share 3 pairs of electrons, the bond is called a triple bond. A molecule can include more than 2 atoms and therefore a number of different bonds. A molecular compound is a compound that is composed of molecules, right? Water, plastic, rubber, those are all molecular compounds. Molecular compounds usually form from elements that are more in the middle in the periodic table instead of on the edges. Unlike ionic compounds, molecular compounds usually do not conduct electric current when melted or dissolved in water. Also, compared to ionic compounds, molecular compounds generally have lower melting points and boiling points. Unequal sharing of electrons causes covalently bonded atoms to have slight electric charges, as you may see on the image in this slide. These charges are not as strong as the charges on ions. A covalent bond in which atoms are shared equally, such as H2, is a non-polar bond. A covalent bond in which one atom pulls harder on the electrons than the other atom, such as hydrogen fluoride, is a polar bond. Polar bonds can create polar molecules. Molecules that have positively charged ends and negatively charged ends. These polar molecules have stronger intermolecular forces, in this case forces between molecules, than nonpolar molecules. Something that you should not forget in this case is to describe the structure of a metal crystal and to identify properties of metals. In this case, a metal crystal is composed of closely packed, positively charged metal ions. The metal electrons drift among the ions, and each metal ion is held in place by a metallic bond, which is an attraction between a positive metal ion and the electrons surrounding it. And what about the properties of metals? Well, we can include luster, malleability, ductility, high electrical conductivity, and high thermal conductivity. Please do not forget about the definition of an alloy, which is a mixture made of two or more elements, at least one of which is a metal. So this is it for chapter number 4 review. In this case, about atoms and bonding. See you later, kids.